Hi, I have a problem on the board here. We have 6 cubed equals a squared minus b squared, and we're asked to find all integer solutions greater than 0, so all positive integers for a and b. And we'll start by noticing that so we have 6 cubed, and we want to express that as a difference of two squares. So we'll start, I'll just mention that 6 cubed is the same thing as 216. And our difference of two squares can be factored as a plus b times a minus b. So what we want to do is we just want, basically, because these are integers, we want two numbers where they multiply to 216, okay? And so for that, what we want to do is we want to get the prime factorization of 216. And the reason we're doing this, I did a couple previous problems, I did 7 cubed and I did 8 cubed. And now with this problem, we have, because 6 is 2 times 3, this prime factorization is going to be a little more complicated, and there's some more possibilities. So let's look at that. So if I write 6 cubed as 2 times 3 cubed, our prime factorization is going to look like this. So then what we want to do is we want to look at every possibility. So then the question is, why didn't I include, let's say, 12 times 18? Because we know that a plus b is always greater than a minus b, and so we can't have 12, because that doesn't make sense. And this is because here we said these are all positive integers. There's no way to add a positive integer and get a lesser number than subtracting it. So then we'll remove this case and we'll stop here. So we have our, 8 possibilities. Now the other thing we can do, I can eliminate a few more things. Let's look at, actually, we'll try to solve this one and I'll show you how we can eliminate some more. So we're saying that a plus b equals 216, a minus b equals 1. When we add these together, the b's will cancel. We'll have 2a equals 217. Dividing 2 on both sides, we end up with, what is that? A equals 108.5. Okay, but that's a problem because up here we said we only want integer solutions. So that's not an integer. So we're gonna have to reject that. And that means we reject this possibility altogether. Now the reason that happened, we'll get an integer solution as long as both of these have the same parity, right? If they're odd, odd, or even, even, we're fine. But here we have an even and we have an odd, and that's not going to work. Because then when you add an even to an odd, you end up with an odd number, and then you end up with a non-integer here when you divide by 2. So when they add, we need an even result. So therefore, we can kind of go through this list and we can find other cases like this. This is 72 is even, but 3 is odd. 27 is odd, and 8's even. This one, 9's odd. Okay, so we eliminated 4 possibilities, but these other 4 should work. So we kind of cut our list in half right there. We have our remaining 4 choices, and what we can do is make a little table, and we just need to solve for A and B in each of these cases where we've eliminated some other possibilities. So we'll start with this first one. What happens when a plus b equals 108 and a minus b equals 2? Add those together, we'll end up with 2a equals 110, so a equals 55. Then we can use this second equation to solve for b, so we can just plug in our a value. 55 minus b equals 2. And quickly, we can see that b is going to have to be 53. What we'll do is we'll check our answer. So we're saying that 55 squared minus 53 squared needs to be 216. So that's going to be 3025 minus 2809, and yes, that will work. So that's a good answer. Let's move on to the next one. So we want to look at the case when a plus b is 54 and a minus b equals 4. So adding these together, we get 2a equals 58. So that means a equals 29, dividing by 2 on both sides. Then we'll plug our a into the second equation, and we get 29 minus b equals 4. That's not a 4. So that means b is 25. A quick check, what happens when we look at the difference of squares of 29 squared minus 25 squared? That's going to be 841 minus 625, and yes, that's going to be 216. Okay, let's look at this line, check this answer. So a plus b equals 36, a minus b equals 6. When we add these two together, we get 2a equals 42, which means a, when we divide by 2 on both sides, a equals 42, so a is going to be 21 when we divide by 2 on both sides. Then we can plug this value back in here. 21 minus b equals 6, so that means b is going to be 15. So we have 21 and 15. A quick check, 21 squared is 441. 15 squared is 225, and so yes, the distance is the difference is 216. Okay, so one more to check. We just need to check 18 and 12 real quick. So a plus b equals 18, a minus b equals 12. We'll add the two equations. 2a equals 30, divide by 2, so a equals 15. We can plug a back in here, so we'll have 15 minus b equals 12, so that means b equals 3. And then this one's pretty easy to check. 15 squared minus 3 squared is going to be 225 minus 9 equals 216.